We tend to imagine the ocean floor as fully mapped, its every sound catalogued. But in 1997, NOAA detected something that shattered that assumption. An ultra-low frequency sound, louder than any known animal, heard across the entire Pacific. Nicknamed the Bloop, the sound rose from a deep rumble of 1 Hz to a peak of 15 Hz over 1 minute. It was picked up by 2 hydrophones, separated by 5,000 kilometers, a distance that hinted at an origin of immense power. Initial speculation pointed to a marine animal, but the bloop's amplitude was far greater than any known creature, including the blue whale. The mystery deepened. What could produce such a powerful sound in the deep ocean? So, how do you catch a sound that spans an ocean? The answer lies in a network of underwater ears, hydrophones, originally deployed for a very different purpose, monitoring the rumble of volcanic eruptions on the sea floor. By the late 1990s, NOAA's autonomous hydrophone network stretched across the Pacific, listening for the crack and grind of tectonic plates. But on May 19, 1997, it picked up something else entirely. A sound so powerful, it was recorded by 2 stations nearly 5,000 kilometers apart. That sound, lasting just over a minute and rising from a low rumble to a higher pitch, was unlike anything in the catalogue. It wasn't a volcano, nor a whale. The hydrophones had caught a ghost, and the hunt for its identity was about to begin. What made the bloop so puzzling was its acoustic signature. Unlike any known geological event, it rose from a deep rumble of 1 Hz to a peak of 15 Hz over exactly 1 minute, a frequency sweep that mimicked a living creature's call. The bloop's reach was astonishing, recorded by 2 hydrophones separated by 5,000 kilometers, roughly the distance from New York to London. That meant it was loud enough to be heard across an entire ocean, a feat no known animal could match. To grasp its power, consider the blue whale, whose calls travel only a few hundred kilometers. The bloop was orders of magnitude more powerful, and its rising frequency resembled a biological call, not a geological event. This combination, a biological-like frequency sweep, colossal power, and a source deep in the Pacific, led many to wonder, could the bloop be the call of some undiscovered Leviathan? The evidence seemed to point that way, but science demanded caution. So, if the bloop was too powerful for a blue whale, what creature could possibly produce such a sound? The answer, some speculated, might be something far larger and far more elusive than any known animal. But size alone wasn't the only clue. The bloop's frequency sweep, rising from 1 to 15 Hz, mimicked the call of a living creature. Blue whales, by contrast, produce calls around 10 to 40 Hz, but at a fraction of the power. The mystery deepened. If it wasn't a whale and not a volcano, then what? The idea of a giant squid, or even an undiscovered species, captured the public imagination. But science demanded evidence, not speculation. The hunt for an explanation was on. So was the bloop really a Leviathan? That's what many assumed, until a different explanation emerged from the coldest place on Earth. In 2005, NOAA researchers proposed a far more mundane source, an iceberg cracking in the Antarctic. Icequakes occur when massive ice shelves fracture or when icebergs scrape the sea floor. These events can produce low-frequency sounds that travel vast distances underwater, and they often feature a rising pitch, just like the bloop. When scientists compared the bloop's spectrogram to known icequake recordings, the match was striking. Both showed a similar frequency sweep and duration. The case seemed closed, but not everyone was convinced. Yet the bloop's source location, near the Antarctic circumpolar current, lined up with known icequake zones, and similar sounds, like Julia and Slow Down, have since been linked to ice. The creature hypothesis faded, but the ocean's secrets lingered. So if icequakes explain the bloop, why does the mystery persist? The truth is, the bloop's acoustic fingerprint was unlike any known icequake. Its rising frequency and sheer power remain difficult to replicate convincingly. The case is not fully closed, and the bloop is not alone. Other mysterious sounds, like Julia, recorded in 1999, and Slow Down from 1997, share its eerie qualities. All have been tentatively linked to ice, but none fully explained, which means the bloop's true source, whether iceberg, creature, or something else, remains an open question. It stands as a reminder that the deep ocean still holds secrets we have not yet heard. So the bloop remains a ghost in the machine, a sound that science can explain but not quite dismiss. Its true source, whether ice or something else, still eludes us, a reminder that the deep ocean keeps its secrets well. The mystery endures. But what made the bloop so unique wasn't just its volume, it was its shape. The sound rose from a deep rumble of 1 Hz to a peak of 15 Hz over exactly 1 minute, a frequency sweep that resembled the call of a living creature, not a geological event. To understand how such a sound was captured, we need to look at the network that detected it. NOAA's autonomous hydrophone array, originally built to monitor seafloor volcanic activity, consisted of sensitive underwater microphones moored at depths of up to 1 kilometer. When scientists compared the bloop to known sounds, the differences were stark. Blue whale calls, for instance, are typically around 188 decibels and travel hundreds of kilometers. The bloop was estimated at over 200 decibels, traveling thousands, a power unmatched by any known animal. The idea of a giant squid producing the bloop captured the public imagination. Giant squids can grow up to 13 meters, but their bodies are mostly soft tissue, unlikely to generate such a powerful, low-frequency sound. Still, the mystery fueled speculation. In 2005, NOAA researcher Christopher Fox proposed a radical idea. The bloop might be the sound of an iceberg cracking or scraping the seafloor. Icequakes can produce low-frequency sounds that travel vast distances, and their spectrograms often show a rising pitch. When scientists overlaid the bloop's spectrogram with that of a known icequake from Antarctica, the similarities were compelling. Both showed a rising frequency over about a minute, with a similar bandwidth. The match seemed to solve the mystery. Yet not everyone accepted the icequake explanation. Some researchers noted that the bloop's amplitude was still higher than typical icequakes, and its frequency sweep was unusually clean. The debate highlighted how little we know about underwater acoustics. The bloop is part of a family of unexplained sounds. Julia, recorded in 1999, lasted 15 seconds and was heard across the Pacific. Slow Down, from 1997, had a gradually decreasing frequency. All have been linked to ice, but each has unique quirks. What the bloop ultimately reveals is our ignorance of the deep. We have mapped only a fraction of the sea floor, and our understanding of underwater acoustics is still evolving. Every new sound challenges our assumptions and reminds us how much we have yet to discover. But what made the bloop so unique wasn't just its volume, it was its shape. The sound climbed from 1 Hz to 15 Hz over exactly 1 minute, a frequency sweep that echoed the call of a living creature, not a geological event. To understand how such a sound was captured, we need to look at the network that detected it. NOAA's autonomous hydrophone array, originally built to monitor seafloor volcanic activity, consisted of sensitive underwater microphones moored at depths of up to 1 kilometer. When scientists compared the bloop to known sounds, the differences were stark. Blue whale calls, for instance, are typically around 188 decibels and travel hundreds of kilometers. The bloop was estimated at over 200 decibels, traveling thousands, a power unmatched by any known creature. And that is the real lesson of the bloop. We have mapped less than 1/4 of the ocean floor, and every new listening station reveals sounds we cannot name. The deep is not silent. It is speaking. We just haven't learned to listen.